All right, let's get right into it. Today, we're going to talk about something that sounds like it's straight out of an old fantasy story, turning rocks into gold. But this isn't magic, it's not alchemy. It's an incredible industrial process called heap leaching, and it's all about some seriously clever chemistry. So, how do you actually do it? I mean, picture this. You've got a whole mountain of rock, just a giant pile of it. And buried inside that mountain are these teeny tiny flecks of gold. We're talking microscopic bits. So the big question is, how on earth do you get that gold out without it costing more than the gold is actually worth, right?
Well, the secret, and you're going to love this, it's a lot like making coffee. No, I'm serious. Just imagine the biggest coffee maker you've ever seen, brewing in super slow motion. Keep that picture in your head because that simple idea is going to unlock this entire process for you.
Okay, so let's get into our first section here. We're talking about the billion-dollar problem, right? It's really all about figuring out how to unlock value from what most people would just call, well, a pile of rocks. And this is what really puts it all into perspective. Get this, in 1 ton of rock, that's like the weight of a small car, you might only find a few grams of gold. Just a few grams, barely enough for a tiny little ring. So you can see why, without a really cheap and super efficient way to get it out, that rock is just worthless. It's waste. This technology, heap leaching, is what turns that waste into actual treasure. All right, so if we're making this giant cup of coffee, first we need to prepare the filter. And this part is absolutely critical. Before you add a single drop of your brewing liquid, everything has to be set up perfectly. Meticulously, even. This setup phase, you could argue it's the most important part of the whole shebang. And that prep work really boils down to 3 key things. First up, you've got to crush the ore down to the right size. Then, step 2, this is only if you need it, if the ore is full of clay, you have to kind of clump it together into little pellets. That's called agglomeration. And finally, number 3, you lay down this huge, heavy-duty plastic liner on the ground. This thing is super important. It's what keeps all the chemicals contained and protects the environment. Now, that first step, the crushing, it's a real balancing act. It's kind of like a Goldilocks situation. You see, if you leave the rocks too big, the liquid can't get inside to grab the gold. It stays trapped. But if you crush them too small, like a fine powder, the whole thing turns into a giant mud pie, and nothing can flow through it. It has to be just right. Okay, so our giant coffee filter is all set up. Now it's time for the main event, the brew itself. And this is a long, slow process. We're talking months long. This is where we let chemistry and a whole lot of patience do the real work. So what's the water we're using for this coffee? Well, it's a chemical solution with a tiny bit of cyanide in it. Now, that sounds intense, but we're talking about a super dilute mixture. It's mostly water. This solution is sprayed over the top of the pile, and as it slowly trickles down through all that rock, it acts like a magnet for gold. It literally dissolves the gold particles, pulling them right out of the rock and into the liquid. Okay, throughout this whole chemical dance, there is one single number that is more important than anything else. Just one. And that number is pH 11. This isn't a suggestion, it's a rule. Keeping the solution at exactly this level of alkalinity is non-negotiable. It's literally the difference between a successful operation and a very dangerous one. So why is pH 11 so critical? Well, there are 2 huge reasons. First, it's about efficiency. pH 11 is the perfect sweet spot for dissolving the maximum amount of gold. But way more importantly, it's about safety. See, if that pH level drops too low, if the solution gets too acidic, it can create a lethal gas. So pH 11 is the number. It's the safety pin in the whole operation. And I just gotta remind you, this is not a fast process. We're not making espresso here. This leaching, this slow chemical soak, it goes on for months. It's all about patience, just letting that solution do its thing as it makes its way through a mountain of rock. All right, so fast forward a few months. The brewing is done. We now have this special liquid that's full of dissolved gold. The next big challenge? Getting that gold back out of the liquid and turning it into a solid again. Remember that giant liner we put down at the very beginning? Well, as the solution trickles all the way to the bottom, the liner collects it and funnels it into a pond. And this gold-rich liquid has a great name. They call it the pregnant solution because, well, it's carrying gold. So from that pond, the pregnant solution gets pumped into a recovery plant. And this is where the final magic happens, in 4 key steps. First, they use activated carbon, kind of like in a water filter, to soak up the gold. Then they use a special hot solution to strip the gold back off the carbon. After that, they use electricity to pull the gold out of that solution. And finally, the grand finale, they smelt it all down into those shiny gold bars we all recognize. So the gold bar is poured. We're done, right? Time to pack up? Not even close. Now comes a hugely important final step, and it's all about cleaning up and making sure the environment is safe. And I think this is a really important point to remember. A mine's job isn't over just because they got the gold. They have a huge responsibility to make sure that site is clean and safe for years and years to come. And how do they do that? Mainly through a really serious water treatment process. Before a mine can officially be closed down, every last bit of that cyanide solution has to be treated and neutralized. They have to meet these incredibly strict government standards. So you can see here, the whole game is to take the water from non-compliant to compliant. Basically, they have to prove it's safe before they can walk away. So when you put it all together, what have we seen? We've seen how careful prep, a ton of patience, some clever chemistry, and a real commitment to clean up can achieve something amazing. It takes what is basically waste rock and turns it into a solid gold bar. It really is an incredible feat of science and engineering, isn't it? And it kind of makes you wonder, right? What other amazing, complicated processes like this are happening all around us, just out of sight, quietly making our modern world possible? It's definitely something to think about.